Class, ready Okay, right. So, mana yang baru masuk, Assalamualaikum and good morning. Alright, so today we continue our discussion about extrema of functions of two variable. Okay, so actually in a partial derivative, we will apply to find the maximum and minimum on the surface. Okay, so in order to find minimum and maximum point on the surface, we have two types. Okay, so we have two types of method. They are extrema of function of two variables, and the other one is a Lagrange multipliers. So actually the purpose of these two methods are equal, sama sebab dia kita nak cari maximum and minimum point, tetapi kita guna different method. Okay, so now we look at this method which is extrema of function of two variables. Okay, so look at this note. So finding absolute and relative extrema are the application of partial derivative. So in this topic, second order partial derivative test will be used to find the relative extrema in a function of two variables. So it is also known as a surface on the point xy. So consider the function xy is a continuous function and define the closed bounded in the region R with the values a, b, and c, d, where a, b, and c, d are the points. Okay, so here we can say the point xy is bounded between the points a, b, and c, d. So here it is present that xy is greater than or equal to ab. So AB is a point and it is less on CD. So based on this inequalities, we define it as xy ataupun point xy is bounded between these 2 points. Okay. Alright, so look at this diagram or this figure 13.64. Okay, so here we have a surface. So a surface, we know it as a z. So z is a function of xy. So function of xy, it is means that ataupun it is represent for a surface. So surface tu maknanya permukaan lah. So before ni kita dah discuss function yang melibatkan one variable. So one variable, it is not a surface, that one is a plane. Okay, so that is a bit different between a function involve one variable and two variable. Okay, so as you can see in the blue one, so this is our surface. So under the surface we have region. So this is a region. So region ni, based on this region we can find the area of a surface. Okay, so region. So how to find the point? So we can bring ataupun the point, untuk point surface ni kita ada 1, 2, 3, 4, 5. Okay, so it will lies on the plane. Dia akan lies on the region lah. So maknanya akan jatuh pada point-point yang berada di atas region yang ini, yang color grey ni. Okay, so based on that we can find the point minimum and maximum point on the surface. Okay, faham Okay, so now we look at this theorem 13.15. So it is explained about the extreme value theorem for a single variable and it is extended to a function of two variables. Okay. Okay, so kita tengok theorem ni. So this theorem, it is about extreme value theorem. So let f be a continuous function of two variable x and y defined on the closed bounded region R in the xy plane. Okay, so bila dia kata xy plane, maknanya we focus on x and y axis. Okay, so kalau dia melibatkan surface, we have another axis which is z. Okay, alright, so now we have two things here. The first one, there is at least one point in R at which f takes on a minimum value. So the R lies on this plane. Okay, so ini adalah R. R adalah region. Kalau you tengok dekat atas ni. Okay, so you can see XY plane berada di sini. Okay, so region berada di XY plane ataupun the region lies on XY axis. Okay, so up here is our surface, permukaan suatu objek. Alright. Okay, so next, number 2, there is at least one point in R which f takes on a maximum value. So based on this theorem, it is explained to us how to find a minimum and maximum value. Okay, so it is it says that maximum and minimum value we can find out based on the region. Okay, faham ya? Okay, so now look at this one. Based on the theorem, minimum value it is called absolute minimum. Okay, minimum value it is called absolute minimum, and maximum value it is called absolute maximum. So in a single variable, it has distinction between absolute maxima and relative maxima. Okay, right. So any question? Ada soalan tak kelas? Jelas eh? So here you can differentiate between surface and region. Okay, so let's look at this one. The definition of relative maxima will be explained in the table below. Okay, so here we have a definition about relative extrema. So let f be a function defined on region R containing x naught, y naught. Okay, so the first one, the function f has a relative minimum at points x naught, y naught if point xy for the function ataupun on the surface is greater than or equal to original point, which is x naught, y naught. Okay, so if we have this condition, we can say that the function f has a relative minimum. Okay, and then lagi kat sini, for all point xy in an open disk containing x naught, y naught. Okay, so number 2, the function f has a relative maximum at point x naught, y naught if the function at point xy it is less than the point at the function at point x naught, y naught. So here we can say that function has a relative maximum if we have this condition. Okay. Alright, so bila you nak lihat gambar rajah ni, this figure. So this is about surface. Okay, surface. And the region lies on XY plane. So region, bayangan dia, shadow dia lah. Jatuh kepada XY plane. And then this is our surface. On this surface, we have a maximum and minimum point. Okay, right. Okay, so any question? Tak ada. Okay, so now this is a step how to find the minimum and the maximum point ataupun relative minimum and relative maximum. So first we need to find the critical point. Okay, so what is a critical point? Definition of critical point, let f be defined on an open region R containing x naught, y naught. So the point x naught, y naught is a critical point of f if one of the following is true. Okay, so this is a characteristic for critical point. First one, derivative respect to x and y on the point, it is equal to 0. And the second characteristic here is derivative respect to x and y and on the point x naught, y naught does not exist. Okay, so this is a definition of critical point ataupun ini adalah characteristic for critical point. Okay, so the critical point is needed to find maximum, to find relative maximum and minimum. So that's why we need to find critical point first, then we can determine the relative minimum and maximum. Okay. All right. So look at this figure 13.66. So here we have a surface. So surface function of x and y. Okay, so on this point, it is about s naught, y naught, z naught, which is the point on the surface, and either relative minimum or maximum lies on the region. So yang you nampak ni adalah region. So maknanya bila you lihat daripada atas from z axis, you will see the curve ataupun the maximum. Okay, tetapi untuk dapatkan point tersebut, it is refer on this region. Okay, so bila you lihat bawah, you akan nampak like macam bayangan lah, shadow of a surface. Okay, So this one is about relative maximum and relative minimum. So based on this surface, we identified that it has a minimum point. So minimum point is down here. Okay, so it is lies on this plane, x naught, y naught. Okay, so in figure 13.66, it is shown the relative maximum and relative minimum. Okay, so theorem 13.16, relative maxima occur only at critical points. In this theorem, it says that if f has a relative maximum at s naught, y naught on an open region, then s naught, y naught is a critical point of f. Okay, so open region. The open region means that there is not bounded region. Okay. Alright. Ada soalan tak kelas? I terus je ni sebab you tak ada soalan, tak ada tanya kan. Boleh Any question class before we go further? Tak ada soalan. Okay, so good. Okay, so next. Yeah? Tak ada lagi.
No question.
Okay. Alright, so next, the second order partial test. Okay, so as mentioned above, dah beritahu tadi, in order to find relative maximum and minimum, second order partial derivative will be applied. Okay, so in this part, it is discussed about the second order partial test. Okay, so look at this one. Second order partial test is used to determine the relative maxima and saddle. So saddle is neither minimum nor maximum. So mana yang ada yang dia tiada minimum dan maximum. So we call it as a saddle point. Okay. In order to classify the relative maxima and saddle point, it is based on the determinant D in the theorem below. Okay, so here we have two situations ataupun two conditions. We have relative maxima and saddle. So relative maxima means that we have a relative minimum, and the other one here is relative maximum. Okay, so all this we call it as a relative maxima ataupun for both situation, relative maximum and relative minimum is a classification for relative maxima. Okay, and the other one here is saddle. So for saddle point, there is no minimum and maximum point on open region R. Okay. Alright, so in order to determine relative maxima and saddle, it is based on the determinant. So ini bergantung kepada determinant. So in this part, we need to find the determinant, okay, where the determinant is based on the second order partial derivative. Okay, so kita tengok kat sini. Theorem 13.17, it is about second partial test. So let f have continuous second partial derivative on an operation containing a point AB, for which derivative respect to x on the point AB equal to 0 and derivative respect to y on AB equal to 0. Okay, so to test for relative maxima of f, consider the quantity of D. So D is a discriminant. So this is a formula for discriminant, which is second order partial derivative respect to x on the given point ataupun on a critical point, multiplied with second order partial derivative respect to y on a critical point minus with a mixed second order on the critical point to the power of 2. Okay, so AB you nampak kat sini. So AB is a critical point. So critical point ni kita kena cari. We need to identify for critical point first, then we will find ataupun we will determine the determinant. Okay. Alright, so based on this determinant, we can identify for relative minimum and maximum and saddle point also. Okay, so look at this one. So the first one, if D or discriminant greater than 0 and second order partial derivative respect to x on a critical point greater than 0, then the surface has a relative minimum at point AB. Okay, so again, what is AB? AB is the critical point. Alright, so next situation, if D is greater than 0 and second order derivative respect to X on AB less than 0, then F has a relative maximum at the critical point AB. Okay, and the number 3, if D is less than 0, then the surface ABF AB. So this one, it is about the point on the surface is a saddle point. Okay. So untuk point dekat surface tu kita ada we have three apa orang kata three terms lah, which is S, Y and Z yang kat sini. Point dekat sini dia melibatkan Z juga. So yang dimaksudkan dengan D less than 0, it is means if D is less than 0, so the point on the surface is a saddle point. Okay. So kena ingat untuk relative maximum and minimum, dia ada pada region. Okay, so the test is inconclusive if D equal to 0. So let's say you have discriminant equal to 0, then we need to use other method. So this is means that for this method is not suitable with the problem ataupun with the case. Okay, so ada soalan? So ini you bolehlah tulis kalau you lupa dalam bentuk begini kan. You bolehlah tulis dalam bentuk begini. Okay, first you need to find the discriminant. So discriminant ada dua keadaan, whether it is greater than 0 and less than 0. So bila less than 0, senang. So this is a saddle point. If we have D greater than 0, so we have two situations here. So we need to look at the second order derivative respect to X. So if second order derivative respect to S greater than 0, so this is means that if the surface has a relative minimum. Okay, macam tu. So if second order derivative respect to 0 is second order derivative respect to X less than 0, so it is means that the surface has a relative maximum. Okay, boleh. So kat mana kita nak apply second order in this part? Okay, right. Any question? Tak ada ya. Okay, so now look at this figure. So yang ni I padam. Okay, so this one kita ada tiga keadaan local minimum, local maximum and saddle point. So local minimum kita tahulah yang paling bawah tu adalah minimum point on the surface. Okay, so based on that we can find out the point on the region. It is similar as a local maximum. So on top of a surface, that is a maximum point. Okay, so how to find the relative maximum for that thing? So we need to look at on the region. Okay, so for saddle point, it is no tak ada maximum dan tiada minimum. Okay, so that we call it as a saddle point. Right, so any question about relative maxima and saddle point? So, relative maxima ni ada dua keadaan lah macam kita sebut tadi. Relative minimum and maximum. Okay. Alright, so now look at this example. So in this example, we need to find the relative maxima of a surface minus s cubed plus 4xy minus 2y squared plus 1. Okay. Alright, so first step, we need to find critical points. So how to find critical points? First, we need to set up a first order derivative respect to x and y on the point ataupun on the surface as a 0. So you set as a 0 for the first order derivative respect to x and y. Okay, so first we need to differentiate respect to x on the given surface. So here we have negative 3x squared plus 4. And a partial derivative respect to y on the given surface. So here we have 4x minus 4y. Okay, so for second order derivative respect to x, y and a mixed order, so it will be used in discriminant. Kat sini kita akan gunakan untuk discriminant. Okay, so now after we set up, so back to this one, kita pergi kepada critical point dulu, how to find the critical point. So after we set up first order derivative respect to x and y as a 0, so we need to solve for this simultaneous equation. Okay, for the first equation, we have negative 3x squared plus 4y equal to 0. And the second derivative and the partial derivative respect to y on the surface is a 4x minus 4y equal to 0. So this one as a second equation. So next we solve for the simultaneous equation. Then here we have x equals to y. So from 2 ataupun from the second equation, we have 4x equals to 4y. Yang ini ya. So we simplify and here we have x equals to y. So next we substitute x equals to y into the first equation. Then here we have values of x and y. Okay, so based on this, we have x is 0 and s equals to 4. So when s equals to 0, so y equals to 0. When s equals to 4, y equals to 4. So it is based on this value. Okay, so therefore we have about two critical points. They are 0, 0, and the other one is 4, 4. Okay, so next, we need to determine the determinant. And we need to look at the situation of determinant, whether it is greater than 0 or less than 0. Okay, so kat sini, yang column, second column ni, so it is about this one, second order partial derivative respect to x on the surface. So here we have negative 6x. Okay, so you masukkan nilai x. Then here we have first critical point 0, 0. Second order derivative respect to x is 0. And the second critical point, which is 4, 4. So the second order derivative respect to x on the surface is negative 24, which is negative 6 times 4. So you masukkan nilai x dan juga y. Kalau ada y, masukkan y. Okay. So next for the second order derivative respect to y. So here we have yang ini kita dapat negative 4, which is a fixed number ataupun fixed value. So dia tak kisahlah sama ada point dia 0, 0 or 4, 4. So the second order derivative respect to y is always negative 4. So you masukkan je. Okay, so next is similar as a mixed second order, which is we have 4 here. Okay, 4. So we just take 4 for the critical point 0, 0 and 4, 4 because it is a constant. Okay, letakkan je. And then we calculate for discriminant based on this formula. You masukkanlah. So second order is negative 6x multiply with negative 6x plus untuk second order derivative respect to x is 0. So multiply with the second order derivative respect to y, which is negative 4. And then minus with mixed order to the power of 2. Then here we have negative 16. Okay, so based on the theorem, if discriminant is less than 0, so this means that the surface has a saddle point. Saddle point pada mana? Pada point 0, 0. Okay, faham tak? Okay, very good. So critical point untuk 4 sama jugalah. You just calculate for second order derivative respect to x, negative 6x. So you enter 4 values. And then negative 4 for second order derivative respect to y. And the mix, it is a 4. So you masukkan je. And then you calculate. Alright, so next we have discriminant is greater than 0. So bila discriminant greater than 0, we need to look at our second order derivative respect to x. So we tengok either it is less than 0 or greater than 0. So if second order derivative respect to x on the surface is less than 0, so it is means that the surface has a relative maximum. Okay, itu je jawapan dia. Alright, any question? Ada saran ke tidak?
No, madam.
Ada Puan.
Yes. Okay.
Nota ni nak dapat kat mana Puan?
Dekat dalam U-Feature ada tak?
Tak ada Puan.
Okay, kalau tak ada nanti tak ada. Tak ada nanti saya share. Sekejap lagi saya share.
Okay Puan.
Alright.
Thank you.
Welcome. Okay, ada lagi soalan? Tak ada Okay, so untuk next, so this is example 9. So example 9 is from June 2019, question 8. Okay, so in this question, it is asked to find or locate all relative extrema and saddle point of surface x to the power of 4 plus y to the power of 4 minus 4xy plus 2. Okay, so this is our surface. And first step, we need to find the critical points. So in order to find critical point, we need to set up first order for x and y as a 0, and then we solve for simultaneous equation. Okay, so now we look at this one. The first order derivative respect to x on the surface is 4x cubed minus 4y. And the first order derivative respect to y on the surface is a 4y cubed minus 4x. So here when you differentiate for y, x remain as a constant. Okay, so yang ini partial derivative. Okay, so next we have a two equation. The first equation here is 4x cubed minus 4y equal to 0. And the second equation, which is based on the first order derivative respect to y on the surface. So here we have 4y cubed minus 4x equal to 0. Okay. So solve simultaneous equation. So from second equation, we have ni daripada sini. So we have 4y cubed equal to 4x. So x is y to the power of 3. So this is our value of x. And then we substitute x equals to y to the power of 3 into the first equation. And then we have values for y. Y is 0 and y equals to 1. Okay, so when y equal to 0, so s equal to 0. So yang ini adalah daripada third equation yang ini. Okay. Okay, so this one is a third equation. So when y equal to 0, so x it will be 0. And when y equals to 1, so s equals to 1. Right? Okay. Okay, so here we have two critical points, which are 0, 0, and 1, 1. Okay. Okay, so now we test on these critical points based on the second order partial derivative respect to x, y, and the mixed order. Okay, so for second order derivative respect to x, we have 12x to the power of 3. So the values of first critical and second, it will be 0 and 12. Okay, and the second order derivative respect to y, which is 12y to the power of 3. So we enter value y, then here we have 0 for 0.00 and we have 12 for the 0.11. Okay, for mixed order, which is the second order partial derivative respect to x and y, we have a constant -4. So we enter this value at the both critical points. Okay, and then we find discriminant based on this formula. And for the first critical point, we have a negative 16. So based on the theorem, if discriminant less than 0, then the surface has a saddle point. Okay, and for next point, which is 1, 1, we identified that the discriminant here is 128, which is greater than 0. So next, we need to look at our second order derivative respect to x. Kalau dia lebih besar daripada kosong, so it has a relative minimum. If the second order derivative respect to x on f is less than 0, so it has a relative maximum. So for this case, at the point 1, 1, the surface has a relative minimum. Okay, boleh? Okay, so that's all about extrema. Okay. So just recap what we have discussed about extrema. So in extrema, we have two situation. Okay, so bila dia kata apa? Extrema, relative maxima, we have two situations, whether it is the relative minimum or maximum. And we have the other one, which is saddle point. So saddle, there is no maximum and minimum. Okay, so in order to find a relative maxima, okay, we need to find the critical points first. Okay, and then we test on the second order partial derivative respect to x, y, and the mixed order ataupun mixed second order partial derivative, and then we calculate for the discriminant. So discriminant have three situations. Yang ini, so if discriminant less than 0, it has a saddle point. If discriminant greater than 0, it might be have a minimum, relative minimum, or maximum. So we need to look at the second order derivative respect to x. So if second order derivative respect to x greater than 0, so it is means that the surface has a relative minimum. So if a second order derivative respect to x less than 0, so it is means that the surface has a relative maximum. Okay, so if discriminant equal to 0, so we need to test using other method. Alright. Okay, any question about relative maxima? Tak ada. Alright, so kalau tak ada, that's all for relative maxima. And then we will continue on the next method, which is Lagrange method. So kita take 5.